Hi Doctor, we are from Group 13 and we'll be presenting our Algebra group project. The group consists of me, Wong Ka Sing, Le Chuyong, Tham Sung Heng, Han Xiao Li, and Pan Jing Hu. And we selected the trigger number 2, which is transportation and logistics. We have 2 questions each for the chapters, which is polynomial, sequence in series, and matrix in our report. Continuing with question 1, I will pass to Tham Sung Heng.
Okay, hi doctor. My name is Tam Heng. So I will explain about the question 1 of the polynomial. Okay, so for question 1, the bridge are built to allow the passage over the obstacle, which in turn makes it possible for ground transportation such as car, trucks, and vans to get to their required destination. Sydney Harbour Bridge is one of 5 bridges in Sydney. Without this bridge, transportation and logistics would not be possible. Next. Okay, so for question A, the Sydney Harbour Bridge is shaped like an arc. The bridge is 118 meters above the water level in the middle of the river, and the bridge is 80 meters over the water at 108.5 meters from the river edge. Assuming the bridge base are at the river edge, what is the length of the span of the bridge? Okay, so we come to our solutions. Okay, we will draw a circle, know the arc easily. So the arc is the portion of the circumference of the circle. Okay, we let the r equal to radius of the cycle, x equal the distance between the water level and the center of the circle, y equal to the horizontal distance from the center of the circle to the point where it is 80 meters above the water level. X. So we extract 2 triangles from the circle, so we can get 2 triangles. Okay, so we get r equal to 118 plus x as our equation 1, and by using the Pythagoras theorem, we can get the equation 2, equation 3, and sub the equation 1 into the equation 2, and we get the equation 4. Okay, next. After that, we sub the equation 1 into the equation 3 to get the x equal to y squared minus 7, 524 over 76. And then sub this x into the question 4. We get equations. Okay, next. Okay, so from that equation, we're using the quadratic formula to find the value of y. Okay, so they got the positive value and also the negative value. We choose the positive value as the negative value is rejected since the y should be greater than 0. Hence, the length of the span of the bridge, okay, we times 2, then we get 454.747 in 2 decimal places in meter. Okay, so for question B, we're assuming the bridge can sustain only 25220 kg of transportation. Excessive wave could cause the bridge to break in the middle. How many motorcycles on the bridge will cause the bridge to break if there are 10 cars, 5 lorries on the bridge? Given the weight of the car is 3,000 pounds and the ratio of the pounds of the car, lorry, motorcycle is 15:25:1. 1 pound is equal to 0.4536 kg. Next. Okay, so from the information, okay, and then we let the C equal to the weight of the car, L is equal to the weight of the lorry, and the M is equal to the weight of the motorcycle, and let the X be our number of motorcycle. So we're using our ratio of the weight car, ratio motorcycle, 15:1 to calculate the weight of the motorcycle. So like this, and then we get the pounds, the weight of the car, which is the pound of the motorcycle, which is 200 pounds. Next. Since the ratio of the pound of the car, ratio lorry, ratio motorcycle is 15:25:1, and then the weight of the motorcycle is 200 pounds. The weight of the lorry is 25 times of weight of the motorcycle. So we times this together to get 5,000 pounds. And also we want to know the weight of the car. Okay, the car is 15 times of the weight of the motorcycle. Just 15 times 200 pounds, we get 3,000 pounds. Next. Okay, and then the equation obtained from the question for the weight of the transportation that bridge can sustain is 10c plus 5l plus xm larger equal to 25220 kg. Okay, since the question needed is in the pound, so we need to convert the kg into the pounds, and then we get the 55599.65 pounds. And then we're substituting the weight of each transportation into each category. And then finally, we get the x larger and equal to 2.99x and then equal to 3. So hence, the weights of 3 motorcycles, 10 cars, and 5 lorries will cause the bridge to break. Then I will pass to Han Xiaowing, the next one.
Okay, now I will present the question of sequence and series. The table shows the total number of parcels delivered by a logistics company from 2014 until 2020. Due to the pandemic COVID-19, the number of parcels delivered had increased significantly since people cannot depart from home to work, school, dining, and others. People were forced to work from home, learn from home, and stay together with their family. When we run out of daily supplies, people cannot go out and buy all the necessary things from the shop, so online shopping is the only way we can use them. So we look at the question. A. Show that the number of parcels delivered by the company is increasing geometrically. We take A1 equals to 600, A2 equals to 630, and A3 equals to 661.5. And then we can calculate that the common ratio is 1.05. Next. For question B, write the general term for the geometry series representing the number of parcels in thousand with n years. The geometry series obtained is 600, 630, and so on. And we know that the common ratio is 1.05. But substituting the common ratio into the general formula of geometry series, we can obtain an equals to 600 times 1.05 power of n minus 1. And n is larger than 1. For question C, by using the number in A and B, what will be the estimated number of parcels delivered by the logistics company in the year of 2025 if the number of parcels delivered is still increasing geometrically with the same common ratio? Counting from year 2014, the year 2025 will be 11 years after it. So we substitute 11 and 1.05 into the general formula of the geometry series. We will get 977.34. For question D, if the number of parcels increased 10% annually, what will be the number of parcels at the end of 2025? Since the number of parcels increased 10% annually, the common ratio become 1.1. So we substitute 1.1 into the geometry series, the general form of geometry series, and we will get 1556.25. For the last question, the logistic company wants to become the most successful delivery company in Malaysia and decided to deliver 1,200 parcels in a single year. How many years would the company take to reach the goal? Okay, we substitute 1.05 into the formula, and last we will get n is larger or equal than to 15.206 and n are almost equal to 16. Okay, that's part for me. Thank you.
Okay. Next, hi, Doctor. I'm Lochio. Next, I will talk about the metric. So the question is, when an A cargo is launched into the A, the gravity pull is back down. This motion is known as a projectile motion. A projectile will travel along a curved route that is the predicable. So a polynomial function can be used to describe its height from the ground and its distance from the launch pad at any given time. Because of the geometry of the projected travel roads, it also known as a parabolic trajectory. So the question A, if V1, V2 until the Vn is a basis for the vector space V, that any vector for any value for the vector V has a unique representation V equal to x1 V1 plus x2 V2 until xn Vm, where the x1 is or real value, the coefficient x1, x2 until xn are called the coordinate of the vector v with the respect order basis v1, v2 until vm. So the question needs us to find the coordinate of the vector v equal to 7, 4 with the respect to the basis u1 and u2, where u1 is equal to 2, 1, u2 is equal to 3, 1. That form a basis to determine the direction of the A cargo. So the solution for the part A, for the question we get that v equal to x u1 plus y u2. Then we substitute the value for u1 2, 1 inside the equation. We get the v1 equal to 2x plus y equal to 7, and the equation 2 v2 is equal to 3x plus y and equal to 4. And next, we write both of equations in the metric notation form. We let A equal to 3, 3, 1, 1. Then both sides are multiplied with the inverse of A. When inverse of A multiplied with A, we get the identity. So we get that A x y equal to A inverse multiplied with the 7 and actually 7, 4. And next. So since the determinant A is equal to -1, that is not equal to 0, thus the matrix A is a non-singular matrix, which means that it has an inverse matrix. So for the equation above, xy equal to inverse of A multiplied with the matrix 7, 4, we get the value of x is equal to -3 and the y is equal to 13. So the coordinate for the vector v equal to 7, 4 is -3 and 13. Next. So for the part B, the question is given a table to show the upward velocity of the A cargo at the 3 different times. So a quadratic expression approximate to the velocity throughout the time t from 5 until 12 is vt equal to a1 t squared plus a2 t plus a3. We need to find the value of a1, a2, and a3. Next. So from the equation that we get, and then we substitute the value of t and v inside the equation, and then we will produce 3 equations: equation 1, equation 2, and equation 3. So we write the equation 1, 2, 3 in the metric notation. We let A is become the coefficient metric of the metric, and B equal to A1, A2, A3, and C equal to the velocity of the A cargo. So A multiplied with B equal to C. Both sides multiply both sides with the inverse of metric A. We get that metric B is equal to inverse of metric A multiplied with metric C. So in order to find the inverse metric of the metric A, so we are using the adjoint method. First, factor metric for the metric S is need to be found as shown in the slide. And then next, okay. So we can get the cofactor, and then we transpose it. After that, we calculate the determinant of the matrix A, which is -84. Since the determinant A is not equal to 0, thus matrix A is a non-singular matrix. It has an inverse matrix. Then we substitute the determinant A and the transport of the cofactor inside the equation. A inverse equal to 1 over determinant A multiplied with the transpose cofactor. And then we get the inverse matrix of A. Since B equal to inverse matrix A multiplied with the matrix C, thus we put inside, and we will get the value of A1 is equal to 0.2905, A2 equal to 19.6905, A3 equal to 1.057. And then I pass to Ka-Sing.
Okay, so for the coding, we chose question 2. And then for the pseudocode, system start, and then immediately we will continue with a repeat loop. Then firstly, we'll clear the system and then print the menu, which is the instruction for a user. And then we'll tell the user to input a selection from 1 to 3. If the user pick 1, then a 4 matrix determinant will be calculated. The algorithm is get the coordinates of the vector and then get two coefficients of the variables for both bases, and then set four given coefficients into an array 2 by 2. And then in a nested for loop, print the given coefficients in matrix form. And then compute determinant of the matrix. If determinant is not equal to 0, then in the nested for loop, compute the inverse matrix using determinant, and then print the inverse matrix in matrix form. And then compute the value of x and y using inverse matrix by multiplications, and then print the value of x and y. Else if determinant is equal to 0, then print matrix is not invertible, and if then return to the menu. And then if the user pick 2, then the program will get 3 velocities from the user, and then get 3 coefficients for the respective variables of all equations, a total of 9, and then set 9 of that into an array of 3 by 3. In the nested for loop, print the coefficients in metric form, and then compute the determinant of the matrix. If determinant is not equal to 0, then in the nested for loop, compute every cofactor in transfer form, and then compute the inverse matrix by dividing every cofactor with determinant, and then print the inverse matrix in matrix form, and for loop. And lastly, the A1, A2, A3 will be calculated by multiplications of the inverse matrix and velocities, and then the values of A1, A2, and A3 will be printed. Else if determinant is equal to 0, then print matrix is not invertible. And then this is the command that if the user pick number other than 1 and 2, and then if the number is 3, it will terminate the system, and then print the names of student. For the coding part, these are the libraries that we use, and then these are the function prototypes. These are the global variables, and in the main function, we use the do while loop and then switch case. And then immediately, I'll be explaining the four metrics, how the system calculates four metrics, 2 by 2 matrix. So first, ask the user to input ABCD, the values, and then show the ABCD in matrix form. And this is the formula to calculate determinant. And then if determinant is not equal to 0, then this system will print that the matrix is a non-zero singular matrix and has a inverse matrix. Then you print the inverse matrix, and then if you calculate the inverse matrix by multiplication of, then if you print out the values of x and y. Else if it is equal to 0, this matrix is not invertible. I will be passing the explanation for 9 matrix to Pan Jin Ho.
Hi, Doctor. I'm Jin Ho, and I will continue to the 9 matrix function. So in here, in this function, we'll be calculate the 3 times 3 matrix with its determinant and the inverse. So first, we use the for loop for these functions, and at the first, we will calculate. We need to input the coefficients for the respective variables. Then after we input the values, and the matrix will be shown, and the determinant will also be calculated in this program. And after the determinant is calculated, and it will show the values. And if the determinant is not equal to 0, it will show that the determinant is not equal to 0, and shows up the non-zero singular matrix, which has an inverse matrix. And after it will be showing the inverse matrix of the input that we key in. So if the determinant is equal to 0, and then it will print, hence this matrix is not invertible. So after this, I'm talking about the functions, the names functions, and in here it will print the group members after the program is quick. So right now I'm going to show the output for our program. So in here we have 3 selection, which is the first one is for question A, second one is question B, and the third one is quick. So first I'm going to calculate the inverse matrix and the determinant for question A. So enter 1. And then the coordinates for the vector V will be 7 and 4. The two coefficients of the respective variables for the basis U1 will be 2, 1, and then U2 will be 3 and 1. So after that, it will shows up the determinant will equal to -1 and is not equal to 0, because the matrix is non-singular and has an inverse matrix. And then the inverse matrix is -1, 1, 3, -2, and it is shown in here. And also the value for x and y is also calculated, which is a -3 for x and then 13 for y. And then we enter 1 to go back to menu. And then we want to calculate the inverse matrix for question B, so we enter 2. Same things, we need to enter the 3 values for the velocities, and it will be 06.8, 177.2, 279. And then also same the 3 coefficients for the respective variables. 25, 5, 1, 64, 1. Also the same, the determinant will be shown in here, which is -84, and then it's not equal to 0, hence it has an inverse. And then the inverse of the matrix is shown in here in decimal places. And the value of A1, A2, A3 also calculated. Like this value will be the same as the solution that we conduct in the problem. So we enter 1 to go back to menu again, then enter 3 to quit, and then it will show up the name of our group member. So that's all from the coding part for our project, and thank you.
Okay, so what we have presented here are only 3/6 of our all questions combined. And then if you have any inquiries for us, feel free to reach out to us. Thank you for listening. Goodbye.